clear? Hello, I'm
Yes,
audible.
sir.
Okay. Uh, shall we start? Okay. So today we'll start our practical number uh, 8 as per the sequence uh, in your syllabus, that is calibration of rectangular and triangular notches. So in pipe flow problem, we have also seen how to find out the discharge with the use of axial meter and orifice meter in the pipe flow problem. But in case of open channel, we have to measure the discharge by the notches. Okay, may be rectangular, it may be trapezoidal, it may be triangular. Okay, so here in your practical, this experiment number 8, and then this is your practical number 7, the calibration of rectangular and triangular notch. So here you have to determine the coefficient of discharge of rectangular notch and coefficient of discharge, that is CD, of triangular notches. Okay. So here uh, what are notches? First we will see notches का आपको नहीं मालूम है क्योंकि जब unit is running, the fifth unit is running, and then we will run the sixth unit. Okay, a notch is the device used for measuring the rate of flow of liquid through a small channel or a tank. It may be defined as an opening in the side of a tank or a small channel in such a way that the liquid surface in a tank or channel is below the top edge of the opening. And flow through wears, wears are actually we are construction to stop the flow of the water or for the hydraulic gel or for backside laminar flow. So here are construction. So we will see the handle. You can see this is nothing but the broad twisted wear. So this is nothing but the wear. Okay, there is no internal thing is there. Then you can see the upstream side and downstream side. The flow is upstream side is almost laminar flow, and downstream side you can say the flow is at the start there is turbulent flow, and then it varies. Okay, so this is nothing but linear. Okay, so uh, then you can say here this is the notches. You can see this is the V type notch. Okay, okay, or you can say the triangular notch, or you can say a triangular notch. Okay, so this is VR, this is notches, and in practical also we can see there you can see the flow. This is the crest height, and then we will provide the notches here. So about the crest, okay, the maximum head you can measure, and this is the component part of the cross section and longitudinal section of here your beard, or you can say. Then there are different classification of notches and beard, that is rectangular knot, triangular knot, and tabular knot, step knot already mentioned, and notches with end contraction, notches without end contraction. Okay. So these are the different types of classification of notches and beard. Okay. According to shape, wear can be classified as rectangular wear, triangular wear, or the trapezoidal wear. So based on the shape, if shape is rectangular, then we will say the rectangular wear. Okay. If shape is triangular, we can say the triangular wear, and shape is trapezoidal, we can say the trapezoidal wear. And according to the shape and the crest, the sharp crest here, if the crest is sharp, narrow crested here, broad crested here, if the length is here is too large, and OB shaped here, uh, and here with the end contraction, here with the end without end contraction. So generally we are measuring the discharge over the wear. Okay. And the discharge formula you can derive by this equation, and we will share this in the class. When this is the discharge of the rectangular wire, that is 2 by 3 CD into L into under root of 2G h to the power of 3 by 4 or 1.5 determine the. Similarly, for the V naught or V here, the discharge will be, you can say, is 8 by 15 CD tan theta by 2 into under root of 2G into h to the power 5 by 2. This is the discharge for the V notches, or we can say the triangular notches. So first experiment we will see the rectangular notches. Here are many such photographs are available. You can see in this. We'll share this also. That you can see the broad twisted here. There is no separation. Okay. So here you can see the broad twisted here, and here you can see the narrow twisted here. You can see the partitions are there. That's why they are called as narrow twisted here. If there is no partition, then they are broad twisted here. Okay. So students, they are joining there. Might be they will miss the attendance. But I am into in. You can see that there is the broad twisted here is divided into parts here, and that is called as narrow twisted pier. Okay. So generally, this for irrigation purpose, to stop the water, we are widening the weir, and to measure the flow, discharge over the this weir, we are constructing the weir. Okay. So for irrigation purpose only, because we have to measure the discharge, what we are coiling for the irrigation purpose. Okay. Okay. So in here you can see the this broad testings are twisted here. This is broad twisted here, and here you can see the sharp twisted here. Okay. This is based on the length of the weir. Okay. Based on the length of the weir. Okay. So much disturbance. The students are joining very late. To avoid this. Okay. Now we will come to our practical part. So rectangular notches is generally used to measure a rate of flow, and rate of flow means the discharge in open channel flow. Okay. तो डिस्चार्ज मालूम करने के लिए जनरली हम नॉचेस प्रोवाइड करते हैं, ठीक है, in laboratory or in practically we are providing the wear that may be the narrow or broad twisted. The basic knowledge you should know and ability to apply the knowledge of basic mathematics, science and engineering to solve the engineering problem. These are the POs already for every practical and every theory class. You should know this PO for the different subjects that different POs are there. For civil engineering, the AICT is set 12 POs. Okay. And that is nothing but program outcome, civil engineering program, and courses are they are called as COs. Courses they are called as COs. Now, relevant course outcome is find the fluid flow parameter in open channel. Practical outcome is use the triangular notch to measure the discharge through open channel. So in this practical, we are using the triangular notch. Okay. We are using the rectangular notch, not triangular notch. So here it is correction. You can write on the triangular notch we are using here. Then the competency of the practical skill. This practical is developed to follow skills of industry, identify competency, apply hydraulics principle in the water carriage system and water retaining structures. So measurement of head over notch, identify components and equipments we are used in laboratory, demonstration process, function of each component you should know, and determine the coefficient of discharge of rectangular notch. Okay. Relevant affective domain related to follow safety precaution. You know that the safety shoes you should anti-skid shoes are there. The safety shoes you should wear, safety goggles and gloves. Okay, you have to wear an apron for the practice. Practice good housekeeping. After the practical, you should clean all the instruments and devices. You must start working as a reader or team member in the practical. You have performed the practical in a 4 to 5 student group in the theory when we are doing the experiment in the laboratory. Okay, so follow ethical practices also. Follow ethical practices also. So this theoretical discharge is two theoretical. That is 2 by 3 into L into 2B h to the power of 3 by 2. Okay. So this is a rectangular notch. You can show the flow is from here, and we are provide a notch here. This rectangular notch. You can say the this is the length of notch, and this height from the bottom is here. It is given h or height above the crest. This is the crest. How height above the crest to the water level. It is nothing but small h. Okay. Or capital H somewhere. It is written as capital. Somewhere it is written small. Okay. Or then you consider the small strip dh at the flow at the distance of h, small h above, and you can find out that you can derive the discharge equation by using this formula by the integration. The resources required is the notch you will require, discharge measuring time, fitted with a scale and the piezoelectric tube. You need stopwatch also to measure a discharge in your tank. Okay, actual discharge. आप टैंक में मालूम करेंगे कैसे, because we are going to find out that is coefficient of discharge CD. इससे पहले हमने orifice meter और meter में मालूम किया था. So you know that two theoretical upon two actual is sorry, two actual upon two theoretical. Actual, two theoretical. This coefficient of discharge. Then you have to precaution to be followed. Reading must be taken in steady or near steady condition. When flow is steady, and for measurement of correct discharge, there must not be any notch and not running in overflow condition. So notches, the flow through the notches should be not overflow. Below this top, this is the top level of your notch. The flow should be below the your overflow. You cannot properly measure. So that is the precaution you should be take while doing the experiment in the laboratory. For measurement of correct head over the notch, the point gauge must be installed little distance away from the test of notch. Test के पास एकदम आपको measure नहीं करना है. You can measure the correct head over the notch. फिर notch के center में जो आपका notch है यहाँ पर you can measure the here you can measure the head. Okay, and then discharge must be varied gradually from higher value to smaller value. Right? And then you have to write down the actual procedure you adopted, actual precaution you have taken. Then you have to fill the observation, this height of the crest and the follow head height over the crest, which one is the you have to measure. And also in the time, the initial reading in the time, which one you can measure, and then final reading in the time for the second, how many seconds that H2. So this H1 minus H2 is the H. Okay, area of tank into H divided by 2. You can find out the actual discharge to actual. Length of rectangular notch L head H putting the formula you can find out the Q theoretical. Okay, and then Q actual upon Q theoretical is nothing but your CD, and then you take the three readings and average of three will be your final. Okay, this is the sample calibration. Measuring tank area you have to find at first. H जैसे भी मालूम पड़ा टाइम मालूम हो तो एक्चुअल डिस्चार्ज Q आपको मालूम हो जाएगा. Q theoretical you can find out using the theoretical formula, and then put that into the coefficient of discharge. You can find out the coefficient of discharge. This is all about the your uh, procedure for the rectangular notches. Okay, so now we will perform this experiment. Okay, so for that I will find your practical plan. So already this is this video lecture, and this video lecture also I will share to you, so you can watch after this experiment number 6, and this experiment we are doing today, that is experiment number 8. One more practical we will do, and this our some practical will complete, and it will get the physical classes for this is 22. So I will go for the virtual laboratory for performing the practical. So you should sit with the pen, paper, and calculator while doing the practical class in virtual lab. Okay. So in oral examination, maybe I will ask some of the students to perform the virtual experiment uh, if they have the computer, and then you can send me the performance of the experiment, and then you can send me the your, what I will say, screenshot. Okay. This is a rectangular notch, calibration of rectangular notch. This experiment we will do. Aim is to determine the coefficient discharge for the rectangular notch. In theory, already theory part we have discussed. A notch is a device used for measuring the rate of flow or discharge of a liquid through a small channel or a tank. It may be defined as opening in the side of tank, which shows the liquid surface. The tank is below level of the fluid. So you can say the height of this above the crest, the flow is there, and this is length of your notch. So this is the rectangular notch, and because this experiment we are performing to determine the coefficient of discharge for the rectangular notch. Okay. Classification of notches already we have seen: rectangular, trapezoidal, and V notch or triangular notch. Step. So we have only scope for the practical of the rectangular and the V notch only. That is, so we are performing now for the rectangular notch, and the discharge for the rectangular notch is 2 by 3 CD into B or L, whatever you can write down under 2B h to the power 3 by 2 is already we have seen. Okay. So now we will perform the practical. Okay. So how to perform the practical? We see the procedure. So this is the procedure. First, start the pump. Open the calibration rectangular notch experiment. So this you can say, if you are starting the V notch, so you have to attach V notch. If rectangular notch, then you have to attach the rectangular notch. Okay. Then you go click on this next button. So you will come here, start the pump. The flow will start. Then next step is open the this fill the your tank, and then over the your rectangular notch the flow will start. Okay. It's not get open, supply of water, and then the flow will start. The initial reading you have to take the crest reading, initial reading water level till the crest, bottom of tank to the crest you have to see, then final reading from the crest and above. The head of water you can find out from this H1 minus H2, and then you can find out the theoretical, find out the theoretical. Okay. So few students they are joining regularly late. One of them is Sakrana. Okay. I think so. You should join on. Then after noting the initial final reading, you can find out the difference in head of water. You can find out right down here. And check it is right. Okay. Yeah, then you can select three suitable discharge using the format 2 by 3 CD D or L and to 2G H by 3 by 2. Put all the value and you can find out discharge. Okay. So CD for coefficient of discharge or the notches is nothing but it is uh, uh, 0.6. Okay. Similarly, you can find out the initial final reading, put the value, then you can find out length and breadth of tank, you know that you can find the area, length of rectangular notch is 15.1 centimeter, you have converted in meter, number of contraction, angle of, it is not, rectangular notch, so can find out theoretical actual discharge by knowing the volume of tank and how many that to fill the tank how time required to put the value you can find out the actual discharge put the value of actual and theoretical discharge you will find out the coefficient of discharge. So you can see that it will be nearby 0.6, 0.62, 0.63 something it will be coming. So you can say that your loss is giving that proper discharge based on this calibration. Okay. So calibration is to find out that notches is working properly. Okay. That is the work process. Now we will see to how to perform the practical. So before that we can go for the self-evaluation. How to find out self-evaluation. So that so we go for self-evaluation. Some question we are asked which of the following used for measurement of rate of flow in open channels such as river. रिवर में रेट ऑफ फ्लो मालूम करने के लिए हम लोग क्या यूज करते हैं नॉट यूज करते हैं कि नहीं और ईयर यूज करते हैं यस और इट इज नो नॉट इज नो head of water over the rectangle notch is 900 mm and discharge is 300 liter per second. Find the length of notch. LCD is equal to 0.6. So you have to given the CD, you have to given the L, you have to given the head. Okay, all this value is given. So put the value. You know the L is 15 point something, and you have to sometimes you have to find out the length of the notch. So length of notch you can find out by using this formula. CD is equal to 2 by 3. Sorry, Q is equal to 2 by 3 CD into L under root of 2G H by 3 by 2. Okay. Put all these value, you can get the answer. So I have got the answer 192. An error of 1% measuring head of water or a tunnel notch produces an error in discharge is 1.5. The velocity with which liquid approach the notch to veer before passing over it is called as velocity approach, which is true. The discharge over the rectangular notch is uh, 2 by 3 CD under root of 2G H to the power of 3 by 2 this one. Okay. So our answers out of 5 all the answers are correct. Okay. Now we will go for the simulation part. Okay. So this to determine the position of discharge for rectangular notch, this is our objective. So here we have to put the rectangular notch and then you go for the next. Start the form. The green button will be start button. The form is started. Now we'll go to the next. We'll open the knob, back clicking the knob here, by rotating the knob, here opening the discharge, then we open next. When the water is started, the initial reading till the crest is 4.6 centimeters. Note it down. Okay, then we have opened this, and then again we are taking the reading 4.6, finally 9.16. H1 minus H2, we have to calculate how much it will be. Please give me. So 9.16 minus 4.6. Okay, so we have to do the minus 9.16.
4.56.
4.56
56.
by, okay. Now you can calculate the theoretical discharge. You know the formula for theoretical discharge. What is the formula for theoretical discharge? So this is the formula for theoretical discharge. For rectangular, that is called triangular. This one, 2 by 3 CD L into 2G H by 3 by 2. So here the value of L is 115.1 centimeter convert into meter. So that is 0.15 meter, 0.15 mm. And then height, just now you have calculated, that is how much you say just now, it is 4.56. Now put all the value in this formula. Okay, we will get the, and under root of 2g, g is 9.81, 2g is 19.62. So find out the under root of that, and you will get the answer. Okay, please give me the discharge value, theoretical discharge value. Please put the values in the formula. Hello.
You said 2.69.
2.69. Huh?
These are theoretical discharge.
Achha. 2.69. The answer is wrong. Please check your units. Hmm? Unit should be proper. They give G is Newton for meter per second square. Okay. H is in centimeter. You have to convert into meter. Okay. So 4.56. If you convert into meter, it is 0.045. Okay. And if you convert the value of L is 0.151 meter. So that should be remembered. Put out the value in meter, then only will get the uh, and the value of CD here you will take is 0.6. Okay, the value of CD you can take here 0.6. Put the value and find out the distance. Okay, please give me fast the reading, correct reading, otherwise we will come out of that. So you know the difference is 0. Which is 0.0456 meter. It is 0.151 meter. So Q is equal to 2 by 3 into CD is 0.6 into L is 0.151 into under root of 2G is under root of 19.62 meter per second square into H is 0.045 0.0456 to the power of 1.5. 3 by 2 means 1.5. Putting all value, you can find out the discharge. Please. जल्दी से बताइए. हेलो.
2.77 into 10 by power minus 3 आ रहा है सर.
पॉइंट्स में बताइए ना. 0.00
0.0027
0.0027
278
यानी 0.003
yes
बराबर. चेक करके देखिए.
wrong. Oh.
हाँ, उन्होंने सेंटीमीटर में कन्वर्ट किया. ठीक है, तो नो इशू. दिस इज सेंटीमीटर में उन्होंने कन्वर्ट किया. वी आर कैलकुलेटेड इन द मीटर. नो इशू. यू टू कन्वर्ट द 9.81 into centimeter, that is 981 centimeter per second square. Now again the initial reading 5.87. Okay. So we take the final reading. It is 13.6. Then again we have to find out the difference. How many difference? 3 readings you have to take. थोड़ा फास्ट बताइए. सेंटीमीटर में रहने दीजिए.
7.77 sir.
7.77. Okay. I will write only 7.77. Next, discharge centimeter क्यूब पर सेकंड में ही मालूम कीजिए. ओके. तो जी की वैल्यू हो जाएगी 981, है ना. 2 into 981, so 1960. Under root of 1960 you have to find out, and then all the value in centimeter already there. Okay. In centimeter if you find out, then q 2 2 by 3 into 0.6 is the PD. 15.1 is the your length by the crest. 2 into 981 centimeter per second square into the difference is 7.77 to the power of 1.5. How much the discharge to reading to? Please. Okay. How much Q2? Please. थोड़ा फास्ट
सर जी
कीजिए.
की वैल्यू सेंटीमीटर में कितना लेंगे?
981 हो जाएगा ना बेटा.
980
100 सेंटीमीटर इज इक्वल टू 1 मीटर. तो 1 मीटर को कन्वर्ट करेंगे तो 100 सेंटीमीटर. 100 से मल्टीप्लाएंगे तो 981 हो जाएगा. तो 981 सेंटीमीटर पर सेकंड स्क्वायर हो जाएगा. बेसिक यूनिट नहीं मालूम आपको.
180.83
क्या आ गया बेटा?
डिस्चार्ज थ्योरेटिकल सर आया. थ्योरेटिकल डिस्चार्ज
कितना? हाँ,
सर 6180.83
6180. अच्छा, फिर करते हैं. कम दे रहे हैं. ओके. इट इज 2384.64 centimeter cube per second. So you check your values. Okay. Write down this. You can check your values. Now next, uh, find out the actual discharge. कैसे मालूम करेंगे एक्चुअल डिस्चार्ज? आपको वॉल्यूम मालूम है. वॉल्यूम इज इक्वल टू वॉल्यूम ऑफ टैंक आपको मालूम है, और कितने सेकंड में आपका घटता है वो मालूम करेंगे. इसको एक्चुअल थ्योरेटिकल ऑलरेडी हम लोग ने मालूम किया. पुट दिस वैल्यू एंड टू एक्चुअल इज 2384. टू थ्योरेटिकल इज 4079. पुट द वैल्यू. यू नीड आंसर.
0.5.
हाँ,
0.58.
0.558.
0.58, sir. Yes, sir.
आगे आगे कुछ और वैल्यू है 0.58.
Yes, 4.5. No.
रॉन्ग आंसर है. ओके, नो इशू. 0.5845 पूरा नहीं लिखे थे इसलिए ये रॉन्ग लिखा है. ठीक है, ये हो गया हमारा अ, अ, ये क्या हो गया हमारा CD हो गया रेक्टेंगुलर नॉच के लिए. ओके, इसी तरह ट्रायल 2 आपको करना है जैसे कि ट्रायल 1 हमने नहीं किया. हाँ, ये ट्रायल 3 करना है. फिर 3 डिस्चार्ज कोएफिशिएंट ऑफ डिस्चार्ज उसका एवरेज निकाल लेंगे. So that will be the calibration of your rectangular notch. Okay, so this is what about your the practical for the rectangular. Okay. Now we will go for another practical. There is assignment. Assignment is also there, so you can do this assignment if you have time. Otherwise, no issue. First thing you should remember that I don't need any uh, manual printed. You have to prepare manual in shop if you need. Otherwise, manual is already provided. You can write down the reading on that. If you don't have that uh, software, computer, you are not able to provide, you can write down the readings in the notebook and do the calculation as per the student wise. Okay. No need of printing from manual. Okay. For oral. Thank you. If there is anything, I will convey the message. So now we will come to the another experiment, just calibration of your calibration of this V naught or triangular notch. Okay. So here this already manual diploma manual already have provided. So all the theoretical parts are similar to the rectangular notch. Okay. Notch is used to measure a rate of flow and discharge in open channel. All these things are uh, uh, related to your triangular notch. Here the discharge formula is different for the rectangle. Okay, and how this formula came into picture? This derivation is there in the architectural book. Discharge over a triangular notch or here. This you have to find out by making the derivation integration of the equation, and the final discharge equation will get, that is 8 by 15 CD tan theta by 2 into under root of 2b into h by s to the power of 5 by 2. Okay, and CD is 0.6 generally well taken. If right angle notch is there, then we can tan theta by 2 tan 45 is 1. So this value will 1. So you can easily find out this charge for the your V notch is only depend on the height of the 1.417 h by h to the power of 5 by 2. If you know the h value, you can find out the theoretical discharge easily. Okay. If in case of your theta is 90 degree, this theta is 90 degree, then only this you can use this formula. Okay. Otherwise, you have to use this one formula. Okay. So this formula you have to use to find out the discharge through the rectangular notch. Okay. So this you can say here in the figure the triangular notch is there. This is the triangular notch. Okay. Height, you observe this height, you can find the discharge. The procedure we will see is similar to the rectangular notch. Theory already similar to that, only the shape of the notch is different here. Here it is V-shaped notch or triangular shaped notch, and here we have seen the this contracted rectangular notch. Okay, and this is the another type, it's trapezoidal. Okay, so here in our this practical is we know. Okay, so discharge formula, how to write the discharge formula, the derivation is given here. Okay, write down from here also the derivation of discharge formula for the V notch or triangular notch. We will see the procedure is you can see the similar for the uh, just you have to fix here the V notch, okay, in your experiment. And here we have fixed here the triangular notch. Now you can open the wall, start the supply, okay, then initial and final reading of the flow below curve crest, initial reading, and total height from the bottom is final reading. Head of water is H1 minus H2. Then you can find out the theoretical discharge by using that formula, and you can find out the discharge also. Put the values similarly that we have solved in rectangular, and then actual discharge you can find out the time taken by the volume of water tank to fill. Okay, volume upon time in second or a minute gives you the actual discharge. Then you can find out this actual discharge to actual. Then you can find out the CD. CD is nothing but the Q actual divided by Q theoretical. Okay, this is the actual discharge versus head, a graph, and you can find out the value or slope. You can find out. Okay, from the graph. So generally we are finding out here calibration of V naught, and this is our aim. So there is also some self-evaluation sheet is given. Question answers are there. You can go through the question answers and solve the question answer. V naught is flow area decreases. In V naught, the flow area decreases as H increases. So it is okay. A right and anchored V notch having depth of water. So here this is the example. So CD is given, depth of water H is given. तो डिस्चार्ज आपको कैलकुलेट करना इन लीटर पर मिनट, यहाँ पर लीटर पर सेकंड नहीं है या मीटर पर सेकंड नहीं है, यहाँ पर लीटर पर मिनट है. So you have to do that. You calculate it. That is 15.67 is coming. 1567 liter per minute is coming. In my case, you can do. So it is nearby 1565 kPa. When theta is equal to 90 degree, CD is 0.6 for triangular notch. सब डिस्चार्ज फार्मूला आपको निकालना है 90 डिग्री के लिए, लेकिन CD की वैल्यू 0.6 है तो इट इज ऑलरेडी गिवन 1.417 to the power of 5/2. V notch is a type of sharp edge here, okay, it is true. And error of one person measuring the head of water in the case of triangular notch is discharge, which is equal to 5/2 divided is nothing but 2.5. So it is 2.5%. It is okay. Now we will go for the simulation process, how to perform the experiment. तो भी नॉच हमने लगा दिया. ओके, रिस्टार्ट द फॉर्म भी चालू कर दिया हमने. नॉब ओपन करेंगे. फ्लो इज स्टार्टेड. नाउ यू कैन मेजर द इनिशियल रीडिंग. Now we measure the final reading. Okay, now the difference of this reading you can 8.85 minus 3.15. So कितना है this? Please give me difference.
5.7.
5.7.
5.7.
Okay. So it is now theoretical discharge you can find out using this formula, h by 15 into under root of 2g into tan theta by 2. So you can find out in the centimeter, put the value. Under root of 2g is under root of 1962. 981 into 2 is 1962. Tan theta, theta value is 1. So theta is equal to, theta is 90 degree, it is here given. And this acceleration due to gravity is also given in centimeter, 981 centimeter per second square. So put these values in discharge formula. Discharge formula is different here. The discharge in triangular notch is nothing but q by 15 into CD into under root of 2g into h by 15 by 2 into tan theta. For right angular V notch, CD is equal to 0.5. So the formula is very easy, 1.417 into s to the power 5 by 2, but you can use that formula, h by 50 into CD is 0.6 into under root of 1962 into h is here is 5.7 to the power of 2.5. 5 by 2 means 2.5. At tan theta by 2, tan 45 is 1. So put all these values, you will get the discharge. Please give discharge. Please, how much your Q theoretical, and then you will find out the Q actual, then CD you will find out the Q for trial 1, Q actual upon Q theoretical. कितना आया Q theoretical? Not taking too much time. सिंपल सा फॉर्मूला भी दिया हुआ है, वैल्यूज भी मालूम है, जस्ट यू आर रिपीटिंग एंड सॉल्व ऑन योर. प्लीज Q theoretical कितना है?
1099.478.
1099.478. This is 1832.
कंसीडर करेंगे ना,
हाँ
सीडी की वैल्यू सर 0.6.
हाँ 0.6 ही है ना theoretical value. Coefficient discharge की वाला V notch और rectangular notch. ठीक है. They are calculated 18.32, no issue. We'll go forward. Now you can open the knob here, close the knob, measure the tank height. It is 31.5 seconds. Now you can A into H by T. Area is 3500 into H is 10 centimeter. Divided by time taken. Time कितना लगा? तो हमने 31.4 सेकंड लगा. Put the value. You can find the actual. Calculate the Q actual. Give the reading. टाइम 31.4 सेकंड लगा आपको. टाइम मालूम है, वॉल्यूम एरिया ऑफ टाइम मालूम है, इतनी हाइट के लिए आपने वॉल्यूम लिया और 10 सेंटीमीटर पे 31.4 सेकंड लगा टाइम को भरने के लिए. तो एक्चुअल डिस्चार्ज हमारा मालूम है. बताइए एक्चुअल डिस्चार्ज कितना है प्लीज.
टाइम कितना है?
31.4 सेकंड आई थिंक सो.
327.83.
तो आपको 327 point
327.83.
इतना कम आया एक्चुअली. जबर कम लग रही है. हेलो. हाँ. Any other?
सर डिफरेंस है सर आ रहा है.
कितना आंसर है बोलिए ना आप आंसर।
4.64.
बोलिए।
1114.64
114
है सर, 1 1 है सर,
114
4.64.
164. Okay, so I will check this, something wrong. The result 114.6 बराबर है आपका।
यस सर, नहीं था।
114.6. Now we can find out the discharge. Put the word discharge value. The actual 114.6 and Q theoretical 1832.5 आया था आपका बराबर। So we'll put the value 1114.6 is the Q actual, Q theoretical 1832.5. How much the CD value?
0.608.
0.608. So this is 0.61. Right, 0.61. It's 0.6 it is considered there. Okay, no issue. 0.60 for 0.6 considered here, no issue. So this is the coefficient discharge for your V notch. Okay. So then you can go for the second trial. Okay. So you can perform this experiment, write down the reading, your own reading on the notebook, and calculate the coefficient of discharge CD1, 2, 3, and then average CD you can find out for the rectangular and triangular notch, and you can write down the this experimental part here, the readings, first reading, quantity, and this resource is here. Level of water, measuring tank, height h1, h2, h1 minus h2 will be the height. टाइम कितना लगा ये मालूम हो जाएगा। एरिया आपको मालूम है टैंक का, एरिया इंटू हाइट डिवाइड बाय टी विल गिव द एक्चुअल डिस्चार्ज। एंगल ऑफ पी नॉच 90 डिग्री यहाँ पर दिया हुआ है, तो आप एक्चुअल में जो लगा लिखिएगा। हेड ओवर द नेक, एच की वैल्यू आप कैलकुलेट कर सकते हैं। इनिशियल और फाइनल लेसिंग एट द क्रेस्ट एंड अबव एट द वाटर लेवल, that difference will be the H. The theoretical discharge, use the formula. This formula you have to use. Okay. Find out the theoretical discharge. So we get the theoretical discharge. Then CD1 is the 0.6 अभी हम लोगों ने मालूम किया। Okay. इसी तरह CD2 फिर वैल्यू आएगी आपकी 0.59 and CD3 आपकी कुछ वैल्यू आएगी 0.61. We'll take the average of this, that will be the your average discharge we have. So this is average coefficient discharge. So likewise you have to calculate, and the result you can write down the coefficient discharge of the given V naught is. Okay. So that's you have to find out the result and find out the coefficient of discharge. So you can write down, and इस तरह आप सॉफ्ट कॉपी में बना सकते हैं अपना मैनुअल, और you can upload in the classroom. Okay, and interpretation of result, conclusion, recommendation, grading. Other most of the references are going KV not, this is not recommended because the difference is very large. If the coefficient discharge near 0.6, you can say that it is nearby the 0.6, and you can recommend this type of notches for practical use. Okay, that is nothing but the calibration. Okay, then this question answer you can write down by typing. By typing you can write down the question answer, what is the question given, and this you have to write it. Still the formula to calculate the discharge of triangular notch, and state the meaning of each term. तो फॉर्मूला लिखना है, और लेंथ क्या है, एच क्या है, एच इज द हेड, Then with the width of your chair, your rear or this width of notch, you need to write down. Okay, G is the gravitational acceleration, acceleration due to gravity. All these terms in this formula. So write down, and by typing you can write down, or screenshot, or किसी को अगर typing नहीं है तो you can write down the logic also, no issue, experiment, no issue, online. Again, but when there is oral, I can able to explain each and every one. Okay, so shall we stop here? No question? कोई डाउट है आपको अभी ये परफॉर्म करने में ये दोनों एक्सपेरिमेंट? And one more experiment, this video experiment is there, that experiment number, this study of uniform flow formula for open channel. So this link I will share to you in your chat box, so you can perform this practical. Your own. Okay. Perform means you have to see the video lecture and then you can write down the readings and uh, chases formula, Myring's formula, and then find out the coefficient of constant of the chases formula and constant of the Myring's formula is n, constant for the chases formula is c. Already that part is covered in the theoretical class. And if you see the video lecture, you will understand. And also that lecture number 44 and 45, you can see, you can understand the chases and the Myring's formula. Okay. And, write down this. You get the uh, link also, and I will share to you on WhatsApp group also. This thing. Links for the practical to perform for the rectangular launch, or practical to perform for the triangular launch, and practical to perform. I will share the links, and you have to perform the virtual practical and video practical. You can see online. Okay. All the students mark their attendance in the chat box. please do the experiment. Some students they are telling that they have the problem because they don't have the PC at their home. So such student they can go to the they are visiting the college perform in the laboratory, in computer department or in our, yes, I think so. Our laboratory also internet connection and perform students. Okay. We already shared with you on the WhatsApp group. And also I will share you on the class. Thank you for joining for today's um, students. We are joining late. Please, I will once again told you that you should put line on. You should not so that should not be your delay or you can. I will stop here. Any question, any doubt, you can share with me. कोई क्वेश्चन है जो बोल नहीं सकते क्या बॉक्स में लिख सकते हैं क्वेश्चन or you will start, you will perform the practical and upload your practical on the Google Classroom. I am sharing on WhatsApp. Try to upload in Google Classroom so that the things are stored here and cannot be